The only thing that I'm concerned about is the
We are live
background.
already, so you can now stop worrying about your background.
Okay, right. All right, so off we go then, right?
Yes, welcome everybody to our first session of the SQD Data Talk. And this series we launched because we're actually very deep into data, but we don't really talk about it enough. And so we decided to launch a series where we just host other speakers who are very deep into the data space and just discuss all those nerdy topics that our engineers usually just keep in the Slack and hidden from sight. And yeah, we're excited to have our first guest today, Aram, who's working with the eRPC team. And he'll be talking to our CEO, Dima, to discuss all of the things blockchain data, data standards, architecture, and open source funding. And yeah, if you have any questions, feel free to put them in the YouTube chat, or if you're watching this on X, feel free to comment below and we'll pick it up. And yeah, so I think I'll leave you two to it and yeah, talk about data.
Yeah, thanks a lot, Naomi, for the intro, and special thanks for Aram for joining us for our inaugural, the first live stream on the data. Really looking forward to talk about all things eRPC and Web3 data in general. And yeah, so maybe we can start with a very quick intro and what you do at eRPC and the story behind it.
Yeah, sounds good. And thank you so much for doing this podcast. It's something that is really needed in Web3 data. I'm really looking forward to the other guests to learn from. My name is Aram, originally from Iran, and I immigrated to the West for all the ideals of a better life and more democratic world and everything like that. And 2020, I was super serious about blockchain, and I left the Web2 world, and I want to get into Web3. And the main thing that was interesting to me was not the tech or the hype, because both of them are cool, but more important for me personally was it's a kind of a duty to my family and everyone who is kind of under the sanctions and everything. And crypto is the only hope we have for those people. So that's why it's super exciting to me. And after a couple of pivots in my startup, we ended up doing eRPC, which is basically trying to improve the RPC experience. It's a pretty kind of short summary of how we got here. I'm super excited to be here.
Yeah, awesome. So 2020 is actually quite a lot of time by crypto standards. So you're like a real OG, and so it's very interesting that after this two pivots, you decided to turn into this very I would say low level part of the stack, namely the data, and maybe you can have. Say a few words about the data infra landscape, the way you see it, and why you decided to focus on the RPC side, right? Because I think there were quite a few projects in the space, for example, Blood Gang, right? Also, I think there were some custom RPCs, and then obviously it wasn't I guess good enough, so you decided to attack this problem.
Yeah, that's a good point. So let me actually start from where everything basically started. So we started doing smart contracts on Solidity and creating dApps. And while we were doing it, we realized, oh, wow, the data is not actually easily accessible. And that's sometimes even takes more time than the Solidity contract to take the right data, to take it in real time. And basically, we were introduced to the Graph and SubSquid and some of the other indexer solutions. And when we were working on with those, we realized, oh, look, one of the biggest bottlenecks of doing indexing with any of these solutions is the actual node and the RPC, under the hood. And this journey was basically 2-3 years. And we built a proxy for our own projects. And one day we were like, hey, this thing is actually super useful. It's saving us a lot of money and improving our resiliency. Maybe it's something that other people want. So we put it out there as an open source project, and shared it with a few people, and quickly caught on, and everybody was interested in it. And we were like, okay, this is actually picking up. Let's put our full focus there. And the reason, in my opinion, that the Web3 data is important is fundamentally is a different thing, is a new phenomenon, in a sense that it's kind of the first time that companies' critical data, important data, is generated and stored outside of their company. Imagine like Uniswap or all these protocols, Polymarket, a lot of these kind of protocols or companies, their data is actually outside their company versus something like Twitter, or that they have their own servers and everything. And this fundamental difference makes crypto data super exciting, and all these challenges that we're going to talk about today. So that's basically the area we were like, okay, this problem is only going to get bigger and more important. Therefore, and everybody's excited about this eRPC layer part of it. Let's focus on that and make it better every day. And after like 4 or 5 months, we got to like 300 GitHub stars, and we are basically pushing every day since.
Yeah, so maybe like for people that are not that much deep into the tech in the space, you can say like just a few words what an RPC proxy is, and like what kind of problem it actually solves, and how it's different from like a traditional RPC, I would say.
So that's a very good question. So in the Web3 world, when you are building an application, you write the core logic in these smart contracts, which is usually like a small compute that you can write some logic there, and transfer this money to this person, or calculate this loan and do something like that. And it generates data. And this data, where is it? It's not in your database. This data goes on the blockchain. And something like Ethereum has certain storage, throughput, certain size, amount of data it can store. Arbitrum has, let's say, bigger, and Solana has even bigger, let's say, data that is being generated and held by these blockchain nodes. Now, for your company to access this data, you have to do something. One way is to run a node yourself. That was usually what people used to do. And the challenge there is like, it's very expensive, maybe 50 terabytes of data, 20 terabytes of data if you have multiple chains, including Solana. And what it means is that practically is not a good idea that every company does that. So some providers, third-party providers, run these nodes and then give you API access. And that's RPC endpoints, essentially. And when you think about Arbitrum and you want to build a dApp there, you usually don't go with one provider, because sometimes that provider might be down, maybe their node lags behind. So you go with multiple providers. You go with Alchemy, QuickNode, Blast, all these other ones. And when you do that, you're like, okay, how do I decide which one to use? And that becomes a problem of load balancing and proxy. And that problem, in the Web2 world, there's Nginx, Envoy, Proxy, all these other solutions, but they are not built for Web3 data, which is about, all these nodes. They might have different latest block. There might be some data integrity issues. Therefore, you need a smart proxy for this RPC, so that you can talk to these providers. And that's where eRPC comes in. Basically improves the resiliency, failover of accessing these RPC providers.
Yeah, that's a pretty good answer. Yeah, so just like I guess to sum up is that I think the main kind of value prop is that out of multiple providers that may break at any time, you can combine a solution which basically goes on the best effort basis. So even if some of them goes down, your app is still online. And this is obviously something that you would expect from a dApp, which by design is supposed to be always online, right? Because like blockchains never stop really, but sometimes all the infra that is around may break, and then kind of the whole value proposition of the dApp itself makes no sense. And that's why it's like very critical to have this kind of resilience and high availability proxy. All right, yeah, and then I guess you've chosen Postgres and Golang as a stack, right? Which I think might seem a little bit untraditional nowadays, maybe because people, I guess, are big fans of Rust. So how would you, like, in general, think about the stack? Is it like, what would be like the most challenging thing to consider in your opinion?
Yeah, that's a very good question. So how we started was from the problem, like what is the problem we're trying to solve, and we have to go for the best solution that satisfies that problem in the least amount of friction and fastest possible. And the problem usually is, for example, not down to 1 millisecond versus 2 millisecond. That's not usually the problem of RPC world. It's like, this node is down, doesn't even give me the data. Please be smart about it. And when it says the block head is that, and this other one says block head is the other, and have a good algorithm there. So we started from that perspective of what is the problem we're trying to solve, and for that, what do we need? We did a bunch of benchmarks on the HTTP transport performance, and Rust was really good, head-to-head with Golang in a lot of cases. And in some areas, Golang was either performing the same or better. And also on this other side, we were familiar with Golang in terms of past experience. So we were like, okay, this is good enough. Let's not do TypeScript, JavaScript, even though we had more experience there. Because it was significantly worse than Rust and Go. But Go was like a good sweet spot. And the way we made the architecture is actually agnostic to the storage. So we have Redis driver, Postgre driver, DynamoDB, and it is possible to actually add more. And we have ideas of more big data providers or connectors to add, like, think about ClickHouse, S3 Parquet, and basically make eRPC agnostic to what is the storage solution, database solution, based on the use case, based on the multi-layer caching. Users can choose the best one. So kind of more on the practical, what works. And right now we started with Postgre because it was a good, like a sweet spot for certain use cases. DynamoDB is amazing for other use cases. And of course, Redis and memory is good for, let's say, close to the head of the chain data. For example, if you run Subgraph and use eRPC, we have a customer just today told us they save 50% of the traffic just by using Redis and memory-based cache, and that's really huge. So each one of those drivers basically can solve certain type of use case.
Yeah, then we're touching a really interesting topic. I would rather say a bunch of topics. So first of all, when it comes to use cases, right? When we started SQD, like former SubSquid, like 3 years ago, the key use case we had was essentially delivering a backend for a DApp, right? And something that I believe you also started with. Nowadays, it seems that the market needs like expanded a lot to also analytics, like backfilling. So how do you see in general the landscape evolving when it comes to the usage of the on-chain data? So based on your experience, how does that then influence the tech stack and the database they would use?
Exactly. That's a very, very good question. And this area is actually very exciting, like how it can evolve, because as a novel core problem, it can have different kind of final forms. So there are a few categories that, like, at least I see from our experience in the past 2-3 years doing data indexing and eRPC now. As you said, in the usage sense, there's like transactional and kind of real-time usage, the dApps and stuff like that. And there's analytical and bulk use cases where you want to get a bunch of data and do some forensic or analytics or something like that. So these two use cases. In a sense of type of data, there is on-chain raw data, events, log, transactions, and there's high-level data, process data, like NFT transfers or swaps or loans or things like that. And these are completely two different worlds, and they have different personas that are using them. And the delivery side, which is the part that you guys have so much experience and is like the layer that needs a lot of work. How do you deliver the data? RPC layer, simple APIs, let's call them legacy way of delivering the data. And there's data sellers like Dune and certain parts of Subsquid archives, I think, selling you the data. And there's a indexing, which is you consume data from a provider like the nodes or Subsquid, and then you do processing on top of it. And so you don't buy the data, you actually manually process and index the data. So these are the three ways of delivery, right? And if I want to kind of think about the RPC, which is like the basic form of getting this data, it is absolutely not built for high throughput use cases. As you mentioned, now people want more data and they want it faster and larger amount of data per second. And RPCs are not built for that. And it goes down to a few things, in my opinion. One is they built the nodes mainly focused on consensus and the logic of the blockchain, and not really with a focus on high throughput data usage. Therefore, it's a simple JSON RPC API, and you cannot expect much from this. And in the ideal world, the nodes are basically pushing the data to some sort of a storage layer, like a Parquet files or some sort of a database, and then the user goes to that database and uses, not calling the APIs. And where's the problem here? The problem is if you want to scale the nodes, you have to replicate a huge multi-terabyte stateful component. It's not like a stateless container that you say, hey, I want 10 container, 20 container in a Kubernetes, and it scales. It's not like that. Every one of them, like Arbitrum, for example, 10 terabytes of data, it takes multiple days to scale up. And that's where this is the fundamental kind of, let's say, limitation. And therefore, things like Subsquid that prepares the data and gives you in a better format for big data analytics, for example, that's a no-brainer. That's the way to go for it. So that would be the way I see the current state.
Yeah, very much the way to think about it. So basically, we go super even radical that RPC should die the way to access the data. So that's why we build this essentially a new type of a database where we put everything that a node used to be used for. So all the raw data transactions are now in this distributed database, which is called SQD network. So you can request data from there. But then we're touching into a very interesting topic that's been debated a lot in the this Telegram group that you've started, I believe. Basically, so once we have this super powerful data lake where you have all the historical data that you can retrieve, then the question is how exactly you're going to query this data, right, and extract. So normally you would either take some specific data, for example, only transactions related to, say, Uniswap, or you would rather take everything. But the question is, what is the right API for this, right? And RPC is great because it is adopted pretty much by all the tooling out there, simply because that is a standard that's been around. But obviously, it's completely unusable when it comes to querying any kind of data, right? You cannot really have any good filtering in there. So that's why we at SQD essentially designed a simple filtering query language specifically for amplifying this. And then we have this pros and cons, right? So how I wonder how do you feel about this? Is this JSON RPC format is here to stay, or eventually people will shift to some optimized API, or they're gonna coexist, or it will be dependent on the read or write use case?
Mm-hmm. So I think we can think about this from the lens of what are the persona of people who are using the data. And in my opinion, there are three categories I see. One, let's call them hackers. These are innovative, small teams that care a lot about being on chain and directly talking to the our JSON RPC, decentralization, maxis, and that kind of persona, which prefers to not rely on any third-party provider. And these people are the ones that are, in my opinion, pushing the boundaries, but they are not going to rely on a Web2 style kind of solution. which is okay, good. But in my opinion, there are not going to be a lot of them. Same as in anything, like the number of hackers is not a lot. The second category, I would say, let's call them companies, which is basically a group of people that are a bit more revenue driven, like they're looking for product market fit, and a lot of what we see as like medium to large brands in Web3, I would say they are part of these companies category. They are creating new things, but they are completely focused on UX and DX. So if you can provide them with a reliable data source as let's say a SQD, and you can provide them with a large amount of data with no reliability issues, they prefer that, because then they can deliver the Uniswap experience to the best way possible and get more crypto adoption. So they are not decentralization maxis. And this is the category, in my opinion, that is going to grow and is really important, because they are more like businesses. And there's institutions, and I want to call them, and these people are not innovating anything. They are like staking providers, they're like traders, and they need a lot of data as well for their purpose, analytics, or doing the best optimized strategy or something. But they're not building anything new. They're just using whatever data is there. So I would say like these are the three categories of people. And when you think about it from this lens, how many people are in each category? I would say the first category, the hackers, probably they're going to stay with JSON RPC until the node supported. So if the nodes drop that thing, maybe they stop using JSON RPC. But until then, I don't think you can convince them to, hey, come and use my Web2 kind of company and rely on our data. The second category, I think this is where we see a shift, at least when we started in 2020, where we were like, a lot of these people who want to build good UX for their product, they quickly go to Web2 data solutions, proper data engineering. They want to get it in a Parquet format, put it in Apache Flink, put it in like Sparks, or do any sort of like DBT maybe, and massage the data. And what they were asking us was like, hey, can you give us the raw data? Let's please not do any sort of compute or indexing or complicated processing. Just give us the raw data. We want to pump it into our data pipelines. And we have a data engineer that is supposed to build our DBT pipeline. And in my personal opinion, this is going to grow and stay, because this is the way Web2 used to do data. So all the tooling and everything is already there. It's just the talent to move and the companies to have the incentive to pay for the infrastructure needed. Like ClickHouse, Databricks, these are going to be the tools that blockchain data will basically occupy a lot, probably. And for these people, it's better if you provide them with some sort of a big data optimized delivery solution. It could be a Kafka topic for real time. It could be Parquet big files for like backfilling, as you mentioned. And they're going to pay for it, they're going to use it, and they definitely cannot use JSON RPC. In terms of cost and performance, it's just incompatible to each other. That's where I think it goes. And in eRPC, like to add to like final point here, what we're trying to do is actually decouple the part that subgraph needs a JSON RPC with the actual data delivery from the node to subgraph. So if eRPC can give subgraph a JSON RPC endpoint, it can talk to it, is a standard thing that it understands, and it gets the responses in 2 milliseconds, and it's beautiful. Then from the eRPC to the outside world, to the nodes, let's say to SQD can give the eRPC the data in huge pipelines, Parquet files, whatever, and then eRPC translates it to subgraph. And our hope is, as a layer, we can help projects to adopt these better models of data delivery and still be compliant to JSON RPC API without losing any sort of performance. It's something that we are working towards, but needs a bit of work on the delivery side. And that's the reason we created this data blockchain kind of group. Get people together, hey, let's come up with a standard so we can give huge amount of data to eRPC instances, and people can already use they don't even need to change their current app. They can just use the same JSON RPC, but now they're getting huge amount of data really fast. So yeah.
Yeah, very interesting. And like you mentioned subgraphs many times. Do you feel that yeah, obviously they were OGs and like starters, right? And there are like a lot of I would say legacy subgraphs were built in the era where we had essentially only Ethereum and not that much data. But then in this high throughput, high TPS world, uh, and like essentially big data world, the subgraphs became really hard to manage and run. And do you still think that subgraphs are going to be sort of a standard? Because based on our like 3 year journey, we really see how the market share declines rapidly. And like if I would say even 1 2 years ago, people were coming and say, yeah, we just want to migrate our subgraphs to something that is faster. Then right now, people more and more come and say we just need a good fast indexer, and we don't really care whether it's like using subgraph or something else, and like see more and more companies actually like either building their own indexing solution from scratch, or they for example use SQD SDK together with SQD network, which by the way under the hood uses this like batch API because it's like generally faster for process batches. So yeah, and also I think the graph itself introduced substreams, right? So and as far as I know, they have like this streaming protocol, which is not really JSON RPC. Yeah, so I would rather say that the subgraphs themselves, like, do you still think that this is something that people will be rely on, or like the indexing space will evolve into some other kind of format? And yeah, essentially, right now, I think there are different ways to run it decentralized. For example, you can run an indexer even in the browser if you want, and also you can just like spin off like different indexers and for example, AVS through restaking, right? So there are multiple options, and they're just like a lot more feasible and easier to run.
Yeah, I agree with everything you mentioned. So I have a few opinions about the subgraph, um, like in general. One is that it was built with the focus on whatever was there in like 5 6 8 years ago, whenever they started, like in terms of amount of data, in terms of throughput of those chains, and in terms of the developers' requirement. They just wanted something to get the data. They didn't care what is a long-term view of that solution, because it was such a big problem back then. So it solved that problem really, really well. But of course, things are completely different in my opinion now. And a few things that I think are a problem there. One is the fundamental core of sequential processing that was good for Ethereum, and probably when Ethereum had less data. So that is a huge, huge blocker when you're talking about like Visa, Facebook, these kind of big companies. They're not going to do one transaction at a time. Yeah. So that's one thing in my opinion, like the sequential processing. And because of that, people are like, oh, wow, actually, this is very slow now. So
sorry, I think something happened with the audio, maybe just like on my side.
Oh, okay, I can hear you though. Yeah.
No, I just like lost what Aram is saying. I can hear myself, obviously. Let's continue. Like, sorry if it was a hiccup.
Yeah, no worries. Yeah, I will start. Can you hear me now?
No, doesn't. Suddenly you just dropped. I'm not sure what happened. No. Okay, can you hear? Can you say something again?
Hello, hello. Working now? No.
I'm very sorry, but I just cannot hear anything Aram is saying.
No worries.
Okay, let's try again.
Hello. Working now?
Okay. Let me just leave and come back. Okay. Sorry for that.
Those are the joys of live streaming.
Yes, the gods of real live demos. Yeah.
It's the gods of WeWork, Wi-Fi, or whatever.
Yeah. Usually for me is when a Bluetooth headphone suddenly connects, but it's always something different.
Okay, now it works. Yeah. Actually, I'm just like on my laptop, so it wasn't even related to any headphones. I don't know what happened. Suddenly, just like the whole sound was cut off, and I couldn't hear anything.
No worries. We can continue from the subgraph side, maybe.
Yes. Yeah. Sorry for the
No
interruption.
worries. No worries. I think I can also hear myself, like a echo.
Yeah. Wait a second. Yeah. Now it's better.
Hello. Oh yeah,
Yeah.
much better. Perfect.
All right.
Yeah, awesome. So for the subgraph, so I have a few opinions about subgraph. When I think about, when they started, like they built this thing for Ethereum throughput, and it was not a lot of data, and people really wanted something to work now, and there was no other solution for them except them building it themselves, and it was really good solution for back then, probably 5 to 8 years ago. I don't exactly remember. And now the world is completely different in the sense that there's high throughput chains, and for that you cannot really rely on the sequential processing. Imagine like Visa, like Facebook, they want to process transactions one after the other. That's just fundamentally not going to work. So you have to have proper sharding, proper horizontal scaling, and you need to rethink the data layer to make it work like that. And because of that reason, I think the trend is away from any sort of sequential solution and towards anything that is about big data. You can distribute it among multiple machines, and like the proper Web2 data pipelines. And there's one aspect to it that I'm not sure how it will evolve, which is that custom scripting logic that is there. And the reason is a bit, ideally in the Web2 world is not like that. It's usually SQL transformations, and like the enrichment or the data is pre-processed on the when it's generated and is put in the like the data pipeline, and on the other side is consumed by some sort of a service. But in this Web3 world, the data is actually coming from the node, so maybe you always want to do some sort of a scripting there, so that might stay. But I don't think it's going to be like sequential processing. Some blockchains are not even sequential in by definition, so subgraph might not even work there. And in terms of like practical deliveries, so many better like indexer solutions came up, from open source side to like enterprise solutions. And as you exactly mentioned, people now mainly care about getting the data as fast as possible in a way they want. So whichever solution does that better, they're going to go for it. And a lot of cases, subgraphs are preferred because they are the kind of a de facto standard. But will it be like that in the next 5 years? Most probably not, especially that the data is just growing, So yeah, that's my opinion on the subgraph and sequential processing indexing.
Yeah, and like we're now, I guess, touching a little bit sensitive topic, at least like for us. I'm thinking quite a lot about that, namely about the economic sustainability. So recently there was a report on the graph, for example, and it says that they earn just around 200K for the queries on the demand side, but at the same time they distributed like 9 million in rewards, which is basically very unsustainable, right? And also at the same time we have a lot of Web2 and like decentralized companies in the space, uh, which makes like the market is like relatively competitive, right? So both like mainly Web2, right? So how do you think the space will evolve, and like how large is the market, judging by the number of active projects in the space, right? So we all expect that okay, Web3 is going to grow, it's gonna be maybe like 10 times bigger, but at the same time, how do you actually make a financially sustainable way when everything is sort of open source? Is it the traditional path, something like in Web2, where we have an open source and software as a service, or there are some Web3 native way to monetize the data? Like, and in general, what you think would be like the most kind of valuable piece of the stack?
Yeah, that's a really interesting question for me. I'm personally super excited to see how it will turn out in the future, but I have a few opinions here. So one is, so when you think about, let's say, I don't know, let's say Subgraph, the way they are kind of hosting these. I mean, initially they had this hosted version, right? And then now they're going towards a decentralized kind of solution. One big personal opinion for me is reading data from blockchain doesn't need the same decentralization design that the smart contracts need. It's fundamentally different. When you want to write to a blockchain, it's a much more sensitive thing. Therefore, you are willing to pay for that, even $1 per transaction, right? But when it's about reading, and you want a lot of people to verify it, but when it's about reading, you generally can trust, let's say, provider A, as long as they give you the data you want, and you're not going to rely on this data because its reading is something to show on the dashboard, is some sort of analytics. You're not going to use it as an Oracle source, let's say. That's the kind of caveat. And in that world, you're going to trust provider A until they go rogue and they give you bad data or they go down, and then you switch to provider B. And this is going to work compared to Web2 because the data you're getting from provider A should not be different than provider B. Like, for example, you want your NFT data, right? You get it from provider A. Provider A simple hash goes down. They don't want to continue anymore. You call this other provider, hey, Alchemy, can you give me my NFT data? They're going to give you the data without anything different, right? So in such a world, will decentralized data delivery reading be actually the ultimate form? My personal opinion is probably not. Probably what will happen is there will be a standard like Subgraph. This is how you deliver me the data. This is the APIs I expect, like the format, the fields, whatever. And then the industry adopts that in standard. And then I, as provider A, I will say, I promise to give you this data based on this standard the best possible way. And if I don't do it, if I die, if I have problems, you can switch to provider B. And then the competition will not be based on who comes up with, like a new kind of data. No, the competition is who can deliver you the data based on that standard the best way possible. And the kind of the trust model will not be like, oh no, I want every single query to go through this overhead, like too much overhead of this decentralized network and like all those incentive structure. So far, I just feel it unnecessary because it's not adding any sort of benefit, but decreasing the quality. Almost all decentralized solutions, from indexers to RPCs, decentralized version of their centralized model, it's worse, like in terms of quality, and is not giving people like 100x more trust. Like, it's not like that you trust, let's say a subgraph indexer in the decentralized world 100 times more than Alchemy API. It's okay, fine. If Alchemy goes bust or charges you so much, that may be a risk, but you would just switch to QuickNode, or you would switch to, let's say in the world of indexing, you switch to SQD to get the data, So that's my let's call it radical opinion, that the decentralized aspect of data reading probably is not going to be as big as the write to the blockchain.
Yeah, very interesting. So basically, we're touching upon the model of trust when it comes to reading the data. And here, I personally think that it definitely depends on the use case. As you said, like, for example, for oracles, you have, and you will probably pay a lot more for the trust. And on the low end, probably like you have some tolerance, for example, for missing data. And by the way, especially for the long tail of the chains, it happens every time. People like just keep the logs, like on the RPC side, like on a provider. And I personally think that this will be probably a very important part of the stack, simply because it's likely that a lot of data, if not most of it, will be consumed by AI agent or any kind of automated rails, right? And then, for example, if it's a trading agent who actually managed someone's money, you really need to trust the data in one way or another. And if it's, for example, an autonomous agent deployed on chain who like takes their decision based on some other data provider, there is no even any kind of mean to, for example, go to some specific person and say, hey, you provided me some wrong data. So how do you then like manage that in the situation where we, for example, Alchemy basically won the market, right? Probably that got a bit tricky.
Exactly. No, actually, you touched upon a really important point. Let me kind of improve my opinion there. That like with the caveat of oracles, like a lot of the use cases that are right now paying dollars, like 10,000, 50,000, annual kind of contracts for the data. Most of it is non-Oracle data. But I think when it comes to Oracle data, indexing in the traditional way is probably not even the right thing, because whoever does that indexing, unless there is a protocol on top of it on a per data kind of integrity check, ZK knowledge proof verification, or something on the data level, then you cannot trust it in any sort of indexing solution. So for that, let's say, category of basically moving data on chain, right? Because that's the point. I would actually say this is probably different than, let's say, a lot of the current indexing requirements. And for that, I haven't like looked into like existing solutions, but like what I can imagine is one kind of variation of something like Subgraph is basically not for the front end usage, it's not for the app DApp usage. It's actually similar to Subgraph, but the idea is to put the data on chain. So or give it as an Oracle data. And for that, like, yeah, exactly as you said, people are willing to pay more per query. But in the current Subgraph model, which you pay for queries, you pay for query of a DApp. That model just doesn't seem like to scale really nicely.
I see. Yeah, that makes sense to me. And maybe we can say a few words about like the your future roadmap for RPC. I have I think have not that much time left, and also I'm really curious how you think about the development of this new generation EVM chains, but also the big mindshare of Solana, and also alternative VMs, right? Like Fuel, like Move, Aptos, Sui movement, right? And like, does it really affect your roadmap? Do you prioritize it one way or another? And basically, it's just another part of the equation when it comes to standardization, right? So, would you expect that there is like one standard kind of subgraph like that fits all in the future, or there will be like a really patchwork of like different data? And maybe it will be something else, even just like some like big database where people just like query whatever data is there.
Yeah, that's a really good question. So the way we are looking at it in eRPC in terms of our roadmap, it gets to technical layer, which is the biggest blocker. For example, it's not the adoption, it's not that like it's a bad thing or something like that. It's just that technically, for example, SVM is completely different paradigm, different entities, different endpoints, and also different data size. Like we have Solana nodes, there's like 50 terabytes of data or something like that. And a disclaimer that our team is not super experienced in non-EVM, so it's like looking at them from the outside. But what I feel is that it's going to be basically two paths for people. One is either they're going to adopt the EVM, some sort of adapter to EVM world, like either become an EVM chain or offer endpoints and the entities like similar or parity with EVM. Or they're going to actually innovate even on that level and do something different. And in the case that they do something different, actually the purpose of it is to not be compatible with the old model. So something like eRPC is going to have a really hard time to adopt because it's essentially a completely new ecosystem, new edge cases, new error handling, failure. Like for example, in EVM we have latest block, finalized block. What if that is completely different in a new alternative VM? So in the short term, we have a lot of demand, for example, for something like Solana, but technically it's really, really big work compared to adding a new EVM chain and covering the edge cases of that EVM. Solana is a completely different world. With the caveat that if it is JSON RPC, potentially we can support a generic JSON RPC proxy in eRPC. People have actually suggested that. They're like, hey, can you make this EVM core of eRPC a bit more generic? Any JSON RPC, just get the method, there's some parameters, and the response, cache that response. I think it is possible to do it, but at least in the short-term roadmap, it's not on our kind of to-do, is something that for now is outside.
Yeah, makes sense. Solana in general is indeed like a completely different beast, and we were even told that normally, like Solana devs are kind of suspicious for using companies who are like doing both EVM and Solana. So essentially, they would prefer like Solana first and Solana only brands over someone who is actually coming from the EVM world and like go and conquer like the Solana, because like many companies tried and many failed. And yeah, I agree that at the end of the day is really about the capacity and like the technical possibility to implement that. So like wrapping up, I think we can maybe show a little bit this blockchain data standards Telegram. Maybe you can say a few words why it was started, like what is like the goal, and what's the discussion there.
Yeah, for sure. Let me actually see if I can share the diagram. So like I will start by saying that like we started this group because we firsthand experienced the challenges of Web3 data, and we identified multiple layers of Web3 data. At the core, we have the nodes and the clients, and these are like Geth, Reth, all these nodes and third-party providers like Alchemy and QuickNode and whoever gives you an API. And it's about raw data, right? And we can say in one layer, like you will store this raw data somewhere. Is either you store it in like SQD archive, or you store it, you don't store it, you just call the APIs maybe. And the next layer on top of that raw storage is what is the schema of this data, like the semantics of that data. Sometimes small fields are different. Sometimes like if you go to Dune Analytics for EVM logs, and you go to Gold Sky Mirror for EVM logs, and you go like to SQD for EVM logs for Ethereum, they might have slightly different kind of a schema. And what it means is that if you use one of them and you want to switch to another one for some reason, it's kind of a vendor, like it's kind of a semi-vendor, like, and ideally it should be like, I just change the endpoint and it works, similar to how the JSON RPC works. Then on top of that, you can say that, okay, we are talking about terabytes of data, and almost everyone wants a specific portion of that data. And usually the access patterns, the way they want it is very similar. Like, hey, I want all the Uniswap, swaps, or I want my own protocol events, or I want all the internal transactions to this contract, or something like that. And we identified that actually this looks to be very common, especially when we are thinking about bulk data delivery. So you're a company, you want to get all the relevant data to your protocol inside your company, inside a database. This kind of query and filtering seems to be possible to have a standard. And a lot of people are actually excited about this layer. And then on top of that is like, how do you deliver me this data? Is it a API call, HTTP? Is it some sort of a gRPC stream? Is it like some sort of a Parquet data? And right now, each company does its own thing. And if we can come up with some sort of recommendations at least, or ideally libraries that people can use, it's another layer of removing the burden from the developers. They can say, hey, I'm using this provider and I don't want them anymore, or they don't have the chain I want, and now I quickly add this other one. And all these 4 or 5 layers are there, and they are kind of standard. And the last layer is basically getting the data to your DApp database and host it for your user or provide it to your user. These are the layers we saw, except the number 6 and 1, which is, or maybe 1 and 2, which is kind of outside, or they are defined by the either the node clients or defined by the DApp developers. In the middle, like probably we can do some sort of standardization, standard schema, standard querying, kind of the same transport solutions. That's the hope of this group, and everybody is really kind of contributing, excited about it. And we in eRPC team, we are trying to kind of carve out time to push this forward, and hopefully at least step by step we make it work. But we need help from everyone. So my action item or request from anyone who's interested or an expert in this, just come join this group and help us ideate and push things forward.
Yeah, absolutely. So we will provide all the details and the links. So just to wrap up, anything else that you would like to share with the viewers and our listeners? Something that you would want to make a call to action, I would say?
Yeah, I think the call to action of joining this blockchain data standards group is like really helpful, getting people's opinion. Of course, trying eRPC and giving us feedback. It's an open source thing. A lot of people are using it. We have, people from like Circle, Moonwell, like Pimlico, Shadow Team. A lot of prominent team like in the Web3 are using eRPC, either evaluating or in production. So the more users we have and get feedbacks and ideas, the more we can make it better, so that everyone's cost is lower, everyone's resiliency is higher. So this would be my second action item, to try eRPC.
Yeah, absolutely. So that's like a really good call to action, a really good wish. So uptime of 5 nines to everyone, and
Exactly.
never going down.
Exactly.
So thanks a lot, Aram, for coming to us, and thanks a lot for like sharing all the alpha and all the insights you have in the data space. And yeah, looking forward to seeing everyone in the blockchain data standards group, and also in our future podcast. Thanks a lot.
Yeah, thank you, Dima.
Yeah, thanks the two of you. And just for the people who are interested in the group, we commented on the video or stream, so you can just find the link to the Telegram group there. So if you're interested in standards, do join. And you can expect us to host another data talk roughly once a month. And if you are somebody who wants to talk about data in depth, then also hit us up. And yeah, we will do a little write-up of this session, so you will be able to catch up on it. And yeah, that's all from our side. Thanks again to Aram for joining us and sharing all of the insights, and to Dima, of course. Yeah, and I think we will see you all around, latest in 1 month, maybe earlier.
Yeah, and don't forget to follow us on Twitter at Hello SQD in order not to miss any other future podcasts.
Okay, well then,
right.
see you there.
Yeah, see you there. Cheers. Thanks, everyone.